This next section of notes is on kinetic energy. We've been through kinetic energy before in honors physics or in regular physics, whichever one you were in, and we know that's basically just energy due to motion. So something's got to be moving in order to have kinetic energy. The equation we've been using for kinetic energy is 1/2 of the mass times the speed squared. Make sure that everything is in kilograms, meters, and seconds before you begin, because if it's not, you'll have a lot of trouble. The unit, just like it was for work, is joules. So we're going to look at the relationship between kinetic energy and work in just a second. Here's the first example problem. We have a 10-gram bullet that has a speed of 1.2 kilometers per second. They want to know what is the kinetic energy of the bullet. Most people would just write the equation down, Ke is equal to 1/2 mv squared, and plug all the numbers in. But because we're in AP, we have to be careful. We notice that we don't have the right units. We need to make sure that we convert the grams into kilograms. So all we do is divide this one by 1,000 grams in a kilogram, and you should end up with 0.01 kilograms for your mass. So this is equal to 1/2 times 0.01 kilograms, and then we need to convert the kilometers into meters. If you do that, you basically just multiply times 1,000, so that'd be 1,200 meters per second would be our speed, and this is 1,200 meters per second. Make sure you square your speed. Lots of people forget to do that too. If you multiply the two together, we should end up with our kinetic energy. So if we take 1/2 of 0.01, so we'll take 1/2 here times 0.01 times 1,200, and then we square that 1,200. We end up with 7,200 joules of energy. They want to know what is the kinetic energy if the speed is halved. So let's go through just a little derivation. We're going to say kinetic energy is equal to 1/2 times 1/2 of the speed that we had in A, and then we're going to square that. If we do that and we go ahead and do some of our math, 1/2 squared will be 1/4, and that would be VA squared. And if you reduce that down, we can then say that that would be 1/4 times 1/2 MVA, oops, make it a capital A, and we take that and square it. So you'll notice that that will be 1/4 of what we had before. So that will be 1/4 of the 7,200 joules. They want to know what is the bullet's kinetic energy if the speed is doubled. So we half the speed. This time we're going to double the speed. So K here would be equal to 1/2 of m times 2 times the speed of the thing squared. If we do that, we're going to end up with 4 times 1/2 mVA squared. So we know that we would quadruple, so we'd take 4 times the 7,200 joules. And that is how we can work through and look at the relationship between speed and what happens to the kinetic energy.